Hi, welcome everyone. I'm Anca Agape. I have been a software engineer at Meta for the past 9 years, and I'm one of the crisis managers in charge of leading response for large outages at Meta. I am very happy to be hosting this panel with our very special guests, in which we will dive deeper into lessons we can all learn for avoiding and responding to incidents. All right, so let's get started. First, I'd like to ask our speakers to briefly introduce yourselves and just in a few sentences, say what is most important to you when thinking about reliability. And I will go in the order of the talks we just had. So first off, Santosh.
Oh, I'm first. Okay. Hey, folks, I'm Santosh. I support the infrastructure teams here at Meta. Reliability, in some sense, I guess it's table stakes, right? That's a job. I'm assuming it's a job of every single person here on the panel and probably the viewers here. But in some sense, I think that's what we need to change up. Reliability should not be the job of the P team, the SRE team, the infrastructure teams. It needs to be the job of the whole engineering organization, ideally the whole damn company. So you can have the best product, the best feature, but if it's flaky, guess what? It's not worth anything. So in some sense, your P0 feature is reliability. And that's what I hope that we can imbibe into sort of each one of our organization and frankly, the industry.
I love this. Yeah, reliability is everybody's job, especially if you're working infrastructure, as we do. So next, Max.
Hi, everybody. My name is Max Ross. I lead infrastructure at Roblox. And when I think about reliability, I think about making sure that engineering teams are always working on reliability, whether we're happy with the health of the system or whether we're not happy with the health of the system. We should always have reliability projects underway, trying to make the system better for our users. And then for me, the question is sort of how do we find the right balance between the reliability efforts and everything else? Sometimes we want to steer it a little bit more towards reliability. Sometimes we might want to steer it a little bit more towards product velocity. But anytime I've ever found myself in a situation where I turn that knob all the way in one direction or the other, it means something has gone wrong. If the entire team is spending all of their time focused on reliability, clearly we are not in a good place. We probably haven't been focusing on it. And if we steer it all the way in the other direction and we're not spending any time working on reliability, maybe it's just 100% on product features, that is something that's going to catch up with us, and we're going to probably end up lurching back in the other direction at some point. So for me, it's all about finding the right balance day in and day out, week over week, month over month, quarter over quarter.
Yeah, I love it. It's a huge challenge. James.
Hi, everyone. I'm James Kretchmar, CTO for the Edge Technology Group at Akamai. When I think about reliability, I guess I think about three things primarily. First is complexity. I think we've seen in the talks here that a lot of what is leading to problems is where we have complexity that we've tried to control for, but somehow got the best of us. So that's what we're facing in terms of preventing problems. I think a lot about communication. I think especially when we're trying to resolve a problem, making sure that everyone is able to effectively communicate between a large distributed team is really important. And then finally, culture. I think making sure that everybody is thinking about it and that has a good mindset towards reliability, as we just heard, is also extremely important.
Mm-hmm. Yeah, I love this. Jeremy. Jeremy?
I'm here. How you doing? I'm Jeremy Hartman, SVP Production Engineering at Cloudflare, so responsible for all of the availability for all of Cloudflare's products. When I think about availability and reliability, think about belts and suspenders quite often, as a matter of fact. And how do we make sure that the system is a partner for all of the service owners out there to make sure that they can operate safely, they can deploy safely, and they're getting the proper feedback loops and proper signals, that they know when something's wrong, and they know when they've accidentally introduced something into the ecosystem that doesn't play very well. So think a lot about that. Thanks.
Yeah, that's true. Building the right tools, it's so important. Next up, Jana.
Hi, thank you. So my name is Jana Iyengar. I'm VP of Infrastructure Services, VP of Product for Infrastructure Services at Fastly. And to the question of what does reliability mean to me, we are basically, Fastly is a platform, and we power some of the largest names in content. And as a result, when I normally think about reliability, I almost always think about the customer pain. And I almost always think about what it means for the users and of our customers. And I want to make it broader than just that. We are a platform, as I said, but the internet is fundamentally a fabric that we are all building the next generation on. And we are in this together. It's not just Fastly, it's all of us. We are in this together, which is why we are here to share and to learn from each other and to figure out how to build a better fabric for the rest of the world to sort of be able to use us.
Thanks so much. And also Hossein, also from Fastly.
Hey everyone, I'm Hossein. I'm VP of Engineering at Fastly. My group is called Network Systems. When it comes to reliability, the way you think about it is that in this industry, we're all trying to push the boundaries of what you can achieve in terms of low latency, higher performance, bigger, more complex systems. And it's inevitable that you hit new class of bugs, things that you've never seen before. One good measure for me to determine if we're progressing in terms of reliability efforts is that only the class never seen before class of issues escape your testing and hits production. And your pre-production testing, your canary process, and everything that you have before globally deploying the code can catch things that you've seen before. And this is something that we pay a lot of attention to.
Yeah, that's true. Learn from your previous incident. Very important. Thank you. And Ian, sorry, I actually did not respect the order.
Yeah, my name is Ian Swett. I'm from Google, and I work on protocols and web performance. And when I think about reliability, I think a lot about blast radius and how to make it so, outages are regional instead of global, or ideally like at an extremely small scale. And I also think a lot about complexity and systems where, in order to have something go wrong, really like 3 or 4 things commonly need to go wrong to really make it into an outage. When only one thing goes wrong, that's just a bug. You catch it in Canary and it's, roll back and it's no big issue. But to really have an interesting outage, typically you need quite a number of things to go wrong. And it's incredibly difficult to anticipate the sequence of events that might be required. And so as a result, you just have to engineer systems as much as possible to be limit blast radius when things do go wrong.
Mm-hmm. Yeah, I love this. Design your systems to help prevent outages as well. Okay, so let's have Prasad.
Hi, I'm Prasad. I'm part of the Infrastructure Services Organization at AWS. I think, the coloring around the edges on where infrastructure stops and where services building is actually getting blurred, at least at AWS. And it's very hard to actually just think of infrastructure without thinking about how services would interact with it. Now, at the same time, we kind of want infrastructure to be invisible. Like, we don't want services to think about, like, where am I deploying stuff? Which lineups am I using? Which data centers am I using? We kind of want those to be well-hardened APIs. So that's one thing that I think about when I think about realities. Like, how do customers as well as services actually use the infrastructure in ways that makes it resilient? And the second thing beyond the blast radius that was mentioned is think about MTTR when you have an event, right? Because when you have these infrastructure events, it's very easy to actually look at the infrastructure event and say your event is done when you've restored, whether it's cooling or power or something else or network or whatever to that particular service. But that's not what customers care about. Customers care about when they're actually up and running. And so that generally, if you think about infrastructure events, the MTTR gets elongated because of how services actually use the infrastructure. And that's what I spend my time on, is trying to understand, like, how does that boundary actually keeps moving, and how do infrastructure teams really understand how services behave, and how do services understand how infrastructure behaves as well? That's what I spend my time on. Thanks.
That's great. Yeah, look at reliability from customer perspective, right? That's so important. So thank you all for the really great talks and for participating in this panel. You already shared so much in the talks, but I'm really happy for this opportunity to dive deeper and use your extensive experience with scale reliability at your organization. To make the best use of this, I'll split the group into two, and I will focus first on some incident management aspects, and then we will dive deeper into resilience systems, so preventing incidents in the first place. So for diving deeper into incident management, we'll talk first with Max, Santosh, Jeremy, Jana, and Hossein. So first, Max, thank you so much for sharing the story of the multiple days outage. I love the lessons that you shared, particularly when to know to switch to a marathon, and that's very important for a really long running incident. And your talk definitely made me think, since I'm one of the people responsible at Meta for making sure we're prepared for any critical outage, it definitely made me want to play out the scenario and just analyze our procedures. So I'm very curious if inside of Roblox, after this incident, if you thought that updating your own procedures to make sure that you're better prepared for any long running outage in the future.
Yeah, so this is funny, but also not funny. But the Monday after that outage was the first day of work for the first dedicated director of reliability that we hired at Roblox. So it was like, welcome to Roblox. We have some work to do. And we've been building up our reliability practices quite a bit since then. And so pretty much everything has changed, and it's hard to tie it to, is it because of the outage? Is it because we really started investing this a lot more? What I will say is, thinking back on the lessons that I shared in the talk, in just our regular outages, we're way more diligent about looking at the less recent changes. We're way more aware of how long we've been firefighting and who might need a break. We are much more aware of the systems that we run that are more likely to need some help coming back up after the system has been down for a while. I mean, we haven't had another outage that looks anything like this since then, but these are all lessons that we sort of take into just day-to-day incident management. And I would say our primary focus right now is on the day-to-day incident management. We haven't written the multi-day outage playbook and put it under glass with an X next to it, but we think about it every day, all day. When you go through something like this, it really influences how you think about things.
That makes sense. Yeah. Yeah, I really loved the way you said that people were still civil and respectful, and it was a really, really exhausting and stressful situation. So that's really important too. Okay, so the next Santosh. So we also dealt with a really extreme outage, right? Being cut out of our network, not something we maybe thought about. And I was on my parental leave during that time, so I was really sorry I couldn't help the team. But you were there through the outage and afterwards. So which are some key lessons that others might learn from, particularly for how to deal with an incident which is so difficult as ours was?
Sure. It's funny, when Max was talking, brought back some interesting memories. My first day at Facebook, I guess at that time, now Meta, I remember being in orientation and somebody knocking on the door, taking me out, giving me the root password and saying the site has issues, get to work, right? So it's interesting that there is an arc to a lot of these stories, right? It starts from a bunch of things and goes there. Listen, I think I mentioned some of this in my talk earlier. So let me try to say this in two tranches, right? There's a bunch of incident management basics that I think all of us know. But what happens in the line of fire, so to speak, when when the site is down, people tend to panic, right? And it doesn't matter, regardless of how long you have been at it and doing this for a long time. So the first thing is to stay calm. Easy to say, hard to do. It's very hard to do, right? After years of doing this, I guess you build up some scar tissues, you get better at it, but you're never 100% prepared for this. So what do you end up doing first? Sort of organize yourself, right? Initially, everybody is in diagnosis mode. You have to probably split it up into multiple work streams. You need to have point people in each one, have a command and controls center to sort of coordinate this. Again, intuitive, but people tend to thrash a bit. This is why assigned roles are so important. You need an IMOC role, you need an incident manager role, you need probably an SME, a subject matter expert role. You probably need a CMOC. Anca, you have been sort of the CMOC and IMOC in several roles of this. So having assigned roles is important because people then know where to point to, who's going to make a call. And this is important when you have situations like this, right? And if you're a leader or a team leader, one of the single biggest sort of value adds you can give the team is being, frankly, the umbrella for the team. Everybody is good natured. They want to come, they want to help, but 50-80% of the help is actually like good natured, but not really useful. So as a leader, you have to figure out how to shield the real team doing the work from getting the help they need and not getting sort of the bulk of like inquiries versus not. So you need a good leader in place, whether it is the IMOC, the CMOC, and a comms person for I can't imagine what Max went through when it's multi days. Imagine the comms you have to work out on that, right? And in places like we do, there's 1 billion users waiting at the gates. So there's a press statement required every hour, right? So stuff like this is what you have to deal with. All of this is typical incident management stuff, but you need to take care of it. I'll talk a little bit about the follow-ups because incident management is not just about getting that stuff taken care of in terms of the incident. Follow-ups, I literally categorize the follow-ups into 20. What do you need to do in the first 24 hours, the next 30 days, the 30, 60, 90-day principle of what you need to iron out so that, not only do you not have a reoccurrence of the incident, it's about the whole similar class of incidents that you end up doing. I think it is Hossein who was saying, if you make mistakes, make fresh new mistakes. Let's please not repeat our mistakes, right? And frankly, one of the biggest things we have learned over the years here is doing the storm exercises we do. We regularly take down data centers and data center regions one at a time in the past. And so we know exactly the threshold at which we can bring it back up and how fast we can bring it back up. And that's literally saved our hide, if you think about it. We knew exactly how fast we could. Once we solved the issue, bringing back a system like ours with literally millions of servers and a global footprint can take down the system again just because of the sheer load it can bring in. But we didn't have to do that because we knew exactly the limits of the system. Why? Because we had run so many DR drills in the past. So this is where all that work pays off. And to the extent, it doesn't matter, by the way, how big your system or how small your system. The actual playbook of how to bring your system back up is super important. How fast can you warm up your cold cache is an example of something that you should know, right?
Yeah, very well said. Yeah, having a playbook for the technical side, but also for the incident management, how we organize, is so important. Thank you so much. So Jeremy, in the Cloudflare incident you presented, you also encountered a rare situation where you rolled back, which usually is safe, but then you started noticing issues. And I noticed that you said that you triggered a P0 all hands on deck response. I'm curious, which are the conditions in which you trigger this response, and what is sort of the playbook, or what happens when this sort of event is triggered?
Yeah, sure. Happy to answer. In this particular case, so the P0 is the highest level of incident at Cloudflare. There's actually a few different ways that this can happen. We do have it pretty well codified, and including some automatic P0s. We have a control plane for Cloudflare that lives in a few data centers around the world. We're measuring for basically API availability and the overall control plane availability. If that drops by a certain percentage, an automatic P0 is declared, and all hands on deck. Everyone's paged across the company. All senior execs, Matthew's paged, the whole thing. Similarly, for global traffic, since we're a pretty large reverse proxy out there, it's pretty important if we're losing a certain percentage of global traffic. Again, that's an automatic alert, and folks are paged. We have there's a condition for a security compromise, obviously, but it also can be transitive for some of our customers. So if there's a major customer security compromise that we need to really get on and make sure that we're covering or helping them out, that can also be trigger a P0 for folks to get involved. And then we have individual edge components themselves that are undergoing end-to-end tests on a constant basis that will also automatically page out for a P0. So things like a major resolver issue with 1.1.1.1.1.1, all the ones are required, or like access, or there's a whole number of edge components that are undergoing those end-to-end tests. So each one of those will qualify as a P0 emergency. P1 has a little bit more of a distinction there. There can be like functionality that can be severely impacted for a while, impacting SLAs. So things can be sort of escalated into P1s, but P0s are really the ones that let's get involved. Things are severely impacted. We need everyone involved right away. So that definitely, this was an automatic page in this particular case. We saw the edge traffic drop and the CPU in each one of the colos actually drop at the same time, and that went right out there. So that's how it works. There's incident management wise, there's a few different streams that are triggered automatically, one of which is customer communications. So to make sure that the incident pages are updated, to make sure that customer comms are going out. We have nag bots that make sure that is happening on a timely basis. So in other words, every 15 minutes at a minimum, we're updating our external customers, and we're also updating the internal customers as to what's going on. Then there's a debug thread. There's an automatic follow-up thread that it's spawned at the same time for incident management. So we keep track of, during the incident itself, we keep track of ideas that the team is having for the retro itself. Very, very useful to have real time. A lot of times thoughts and threads can fade away over time. So all those streams are pretty important. So that's how it works.
Yeah, I love that you have work streams which get triggered automatically. That does help a lot. Thanks so much for that.
Sure.
So Jana and Hossein from Fastly, you share really great lessons about investigations and long-running investigations. But I'm curious if you had any advice when it comes to investigations during an incident, during those like high stress times of an incident.
I'll take that. I think Santosh actually referred to one of the key points there. Is that's actually true. A lot of it is up to the responder to remain calm. Long time ago, 20 years ago, when I started building networks, I remember a situation where we had our engineering desks and NOC being in separate rooms that were distanced. And back in the day, automation was in its infancy. So I remember that every incident that we had to respond to, people wanted to rush to the large monitors in the NOC to see the stats. It's like 20 years ago. And back then, I remember that when everyone elected to run, but I was actually walking towards those monitors because I realized that I might save a few seconds by running, but that added heartbeat and stress and anxiety that it brings, it actually has a long-lasting impact in my ability to troubleshoot the situation. What we do here at Fastly, several simple things. I'm pretty sure a lot of the audience are using the same practice, but I'll highlight a few things. We try to limit the external stress factors. Like, for instance, Jeremy brought up that the way you prioritize the severity of the incidents, that's basically what the responders really need to know. Like, they don't need to know a running list of customers that are notified, that are not happy and are pinging the support and are asking for an explanation. So when you tag an incident as P0 or P1, that carries enough signal for the responder about the severity of the issue. They don't need to receive any more, running documentary of what's going on in terms of how customers are feeling about the incident. The other thing is we kick execs out of all incident responses. So, even if they join, the rule is that they have to remain on mute all the time. And that's also very helpful. And the ARMAC plays the role in handling communications between them. And then after that, it purely becomes an engineering solving a puzzle problem for the engineers. And I found that extremely helpful.
Yeah, that's so important. I love that you mentioned this, like letting the engineers focus on solving the problem, and then everything else on like incident management, the IMOCs, the other people can help with. That's great. Okay, so thanks so much for all the insights on incident management. We are going to switch gears really fast now and dive deeper into how we can make our systems more resilient, so avoiding incidents in the first place. And here we're going to talk with Prasad, Ian, and James. And we're going to start with Prasad because I know you need to leave very, very quickly. So Prasad, in the instance that you shared at AWS, I love like all the principles that you mentioned, which are limit your blast radius, have redundancy, and help self-healing automation. That's again very important. I am curious if there are some ways in which you test that your systems are actually complying with these principles as well.
Yeah. Thanks. Well, first, sorry for having to leave a little bit early. Unfortunately, I have a prior commitment, but it's a super interesting topic, so I would have loved to stay for the whole session. I'll give you some specifics on how we actually do it. Like, first of all, like, as I said in my presentation, I've been a software engineer my entire life. So many things that I actually think about in infrastructure comes from some software concepts. And it's the same concepts, whether it's actually infrastructure or services or whatever the case might be. And generally, when you actually build systems, when you actually build it as active passive systems, they're always prone to actually failures when you need those passive systems, right? That's why you actually try to build active systems, that you're always executing the same code paths that are actually executed on a regular basis. Unfortunately, in infrastructure, you cannot do that all the time. So you resort to some kind of failover. It's like, if you have a primary database and a secondary database, like you kind of have to actually make sure the secondary database is up to date and you can fail over to it, right? Infrastructure is similar. We have a few things that we do to make sure that we can actually execute on this failover. Like, I'll give you a specific example. I talked about how we have a lineup, which is basically utility plus a generator. And then we have this thing called catcher, which is actually available for us to move any lineup to. And before we execute on this transfer that I talked about, we actually first test with load banks whether the catcher system is actually able to take the load, right? And if you don't test that, that means if you don't test your backup before you actually do the failover, then you've not actually really solved for anything, right? Because otherwise you're just going to drop customer load, which is not very useful. Beyond that, we also have a few set of other things that we do to make sure that we can like self-healing systems work. So I'll give you an example. When we actually launch like new instance types or new SKUs on a particular lineup, what we do is that we go through a vetting process and we actually push the system to upper bounds of the limits. And this is the place where you actually assume that there is correlated workloads across that particular setup, and you push it far enough along to make sure that the systems can actually behave for it. And that allows you to test things like self-healing systems, right? Because now you actually have exceeded a certain threshold that you wouldn't normally expect customer load to operate under. And the good thing is you can do that prior to actually putting actual customer load on it, even though it's on this exact same production systems that you actually have on infrastructure that you already have. That's the second kind. And the third kind is that we're constantly in the process of building new regions and building new data centers, which allows us to actually use our scale to be able to do that testing of failover as well. In fact, every new region we do things like game days and all that. And we learn a lot from those game days. Like when you have to actually understand about static stability, like for instance, you take power off a lineup and then you expect these systems to actually automatically come back up. You want the control plane systems to actually know about state. And you find static stability issues on that, right? Because you've added dependencies on services that you did not actually expect before. So you can test those things. So those three things are examples of things that you can do prior to us actually doing actual failover like that.
Mm-hmm. Yeah, I love it. And using the data centers turn off, or like we use like when we take down the data center just to test like our storm exercise, we would run all sorts of tests just to make sure our infrastructure is resilient as we thought.
So thank you very much for the time. Unfortunately, I have to bail, but this is a super interesting exercise. Thanks for doing it, and thanks for inviting me. Thanks.
Okay, so next, Ian, I want to dive deeper into something you mentioned in your talks. So for the instance that you presented from Google, you had a rare situation in which you canared the config change, which is like a regular practice on just a small subset of tasks, but then all the other tasks started crashing. And that's honestly, that's quite scary because that's like a regular procedure that we do for config changes. So I'm curious if there was any follow-up at Google for this type of scenario, for either detecting maybe dependencies like this, or for just limiting the blast radius in case this happens.
Yeah, so we actually did both. So we both explored and tried to brainstorm all possible contagion risks that we could think of in different systems, at least all the systems that interacted with load balancing. And we did identify some others that were not directly related to resumption, and added testing, fuzzing, and such for those. But each situation actually was different. So there wasn't a one-size-fits-all sort of answer of like, just more fuzzing will help or just more multi-version testing will help. So each kind of scenario required a little bit different process in order to make sure that we were not vulnerable to it going forward. Additionally, and this is a longer standing project, but there are various types of isolation that we're in the process of adding. So I mentioned not being able to resume TLS across regions in my talk, but there are other types of isolation that we're looking at adding both between different projects or customers, as well as kind of between different regions. And so any type of isolation like that at least limits blast radius. And so when these things do happen, they're much less severe. So certainly if we could have isolated it, so only those few racks that were being canaried were impacted by this, the impact would have been tiny, for example. So we can't do that today, but we're definitely actively working towards that direction.
Mm-hmm. Yeah, that's a hard problem with discovering these dependencies. It's really hard to. Thank you. So the last point, like, very important, James, for the presentation you had at Akamai, I really liked how you said you have these principles that you apply for config changes or for other things. So I'm really curious to hear if there are some other principles that maybe you have. It can be config safety, but anything related to reliability.
Sure. Yeah, I'm happy to give some examples. In fact, one of the things that we did coming out of the incident was to make sure that we've really got the principles written down in a clear way for everyone to understand. So it's top of mind. I guess in terms of configuration best practices, I'm tempted to go to one of the fancier ones because it's the most interesting. But before I talk about a fancy one, I mean, really, some of the most straightforward ones actually turn out to be the most important. So, for example, even just knowing for a given configuration change, who made the change and for what reason. There's nothing worse in the middle of an incident where, you've figured out what the thing is that broke and you've got a button to push to revert it and fix it, but you're reluctant to use it because you don't know what collateral damage it'll do, right? If the change that was being made, is it totally safe to revert it, or is it going to break some customer? So things like really good tracking of, what change was made by who, when, that type of record keeping is really important. Other things that I would think of on the more classic, straightforward end, having a fast restart for components is important. You might crash. And that's okay. And if you can crash and come up real fast again among all the instances that you have, then you can kind of mask over it being really impactful to end users. But if you have a component that is going to crash on a new config and then take a very long time to restart, you're extending the length of your outage in a way that could make it much, much more impactful than if you could do a fast restart. Reversibility is one. This is another one that you think of it as obvious, but in a big distributed system, there are types of changes that you can make that actually you can't reverse, you can't get backed out of unless you've made a point of making sure that you can. So, even a step worse than having a button you don't know how to use is there's no button because you realize this change, there's no way to undo it. And that makes you really stuck. So those are some of them. I guess the fancier one that I'll talk about is, everything I've talked about so far is a best practice that is related to safety that you can apply as a configuration change is going out or being made or just after it, and it caused a problem and you want to revert it. There's a harder situation, and some of the incidents here talked about it, where you've got a configuration and at rollout time, it didn't cause a problem, but then much later on, something triggered that configuration to do something problematic. Now, at that stage, your rollout's done. So what are you going to do to try to deal with that? One thing you can do, and this is harder, so it's sort of, you have to figure out where it makes sense to do this, is if you can automatically correlate some type of bad thing happening on the network with a particular configuration, then you can try to automatically employ mitigations for it. So for example, you might not want to roll back. If you can, that's great. But as someone else pointed out, once it's been out there for a while, the rollout is kind of more impactful. So you're not sure if you want to do that. But maybe if you've correlated some bad behavior that's due to something exogenous, that's related to one particular config, you could isolate the traffic that is being allowed to use that config, or take other mitigation mechanisms to keep that contained. So that's a sampling. There's really a lot of things that can be done here. One of the arts to this is to make sure that you figure out what's the right level of mitigation and best practices to be putting in for any given circumstance. But there's a lot that can be done.
Mm-hmm. I love it. You share so much. Particularly, having revert procedures that you just need to also test them out, right? But knowing that not always it's safe to revert, and I know, like from Mac's talk, like sometimes it's not obvious what to reverse, right? If it's been like more than 24 hours, so
And
lots of challenges.
Sorry, go ahead.
No, please.
And at design time, you need to make sure that you've made it possible, right? That you have not painted yourself into a corner systems-wise.
Exactly.
But yeah,
exactly. Having this principle and using them at design time, it's gonna help. Yeah, perfect. Thank you so much. So we have only about, I think, 5 minutes left, so not much time. But we did receive questions from the live stream, so I would like to go through this. So we have 3 questions. So let's go first for Ian. We received the question. So with the classic issue of DNS updating wrong, some clients cache that DNS rolled back issue is extended because some clients have the wrong cache state, be an example of a contagion incident?
Yeah, I think that's an excellent example, because yet again, you have something cached in another system that, obviously the DNS system, you have no direct control over, and you can't do any sort of rollback. You just have to wait until the TTL expires. And so in particular, if whatever DNS entry you created, sending traffic to the wrong place is bad. But if for some reason there was actually a bug where like it caused a crash in a piece of infrastructure, whether it was client or server, that could be extraordinarily bad, and it could take, depending on what the TTL is, a very long time for it to purge from the system.
Mm-hmm. And these are the harder ones to find, right? And fix it and remember some similar incidents to Meta as well. Okay, so another question for Max from Roblox, from Bernard. I understand that the on-prem desire for core data center, but I'm curious what the return of investment is for having your own edge data centers rather than relying on Cloudflare, Akamai, and others. Interesting.
Sure. Thanks for the question. I'm not going to get into any sort of financial numbers here, but our edge data centers are running all of the code that is written by the creator and developer community that builds all of the experiences, like the millions of experiences that are on Roblox. Those are built by other people, and we are running their code at the edge. So there's all sorts of amazing vendor solutions out in the marketplace, and we use many of them. But when it comes to what we're actually doing at the edge, that's sort of the core of what Roblox does, is that we have figured out a way to support massive multi-tenancy across all of these edge core data centers, running other people's code with extremely low latency and an interactive gameplay. So those particular vendors like amazing products and they make sense in certain places. But when it comes to figuring out how we're actually going to run all of this code that's provided by the community, that's something that we feel like we have to do ourselves. Like that's the product in many ways. Thanks for the question.
Yeah, excellent question indeed. Okay, and the last question from the stream for Santosh from Data Patil. Always so much to learn from critical incidents, great insights shared. I didn't understand on what mechanism you build in the storm to avoid power surge when you open up the traffic.
Fair question. So I think it's important to give context on what storms are in the first place. Storms evolve from the point of view that, hey, you take down a component, a system, a bigger system, and how does the rest of the infrastructure respond? So that's what we do. Over the years, we have graduated from taking a server, a rack, a data center building to a whole data center region down at a time. At that time, we're talking about maybe hundreds of thousands of servers going offline at the same time. So that creates a real capacity deficit in the system. So how does the rest of the infrastructure respond? And what systems do we build in response to that is basically the learning you get from storms. So over the years, we built up things like, overload protection, DEFCON, wherein we can turn off certain features one at a time and see how the system responds. So the biggest things that I guess helped us during the outage was we know exactly when mechanisms like overload protection will kick in. We know exactly the right amount of QPS before you start load shedding. We know how long it takes to warm up a cold cache, things like that. So you know exactly not only the sequence of things to bring up, but how fast to bring each one up. And we can have multiple things like that happening in parallel. So when you add all of them up, so you basically have a playbook. And you go in an outage from figuring out what to do to just going into playbook mode, execution mode. It actually becomes much more routine. It makes it very, very routine. So that is the single biggest thing, I guess. So it is not one or two things. It's that whole playbook you develop over the years.
I agree. And our Storm playbook definitely helped us in many, many situations. I don't know. Okay, so we're just at time. So I'd like to wrap it up by really thanking all our speakers. We appreciate so much. We know it's not easy. You need such a degree of vulnerability to talk about the incidents that you've had. But we believe that it is very, very valuable because we all as an industry can just learn from each other and improve our systems and our incident response. So really thank you all of this for advancing the industry as a whole, I think, by participating in this very first reliability at scale event. Thank you so much.